Hi everyone, welcome back to How to Math. Today I'm going to explain problems 11 through 15 from the AMC 10A 2021. Problem 11. Emily sees a ship traveling at a constant speed along a straight section of a river. She walks parallel to the riverbank at a uniform rate faster than that of the ship. She counts 210 equal steps going from the back of the ship to the front. Walking in the opposite direction, she counts 42 steps of the same size from the front of the ship to the back. In terms of Emily's equal steps, what is the length of the ship? Okay, so let's say the length of the ship is x. Then when Emily travels 210 steps, the ship will travel 210 minus x steps. In this way, when Emily travels 210, she'll travel from the front to the back. So now we also know that when Emily's traveling from the front to the from the back to the front, she's going to go 42 steps. The ship at the same time must travel x minus 42 steps, so Emily again will walk x steps in the opposite direction. So we have the ratio 210 over 210 minus x is equal to 42 over x minus 42. So we can cross multiply and we have 210x minus 42 times 210 is equal to 42 times 210 minus 42x. We move the 42 over to the other side and we have 168x is equal to 84 times 210. We divide by 168 on both sides and we get x is equal to 105. So that gives us an answer of D, 105. Problem number 12. The base 9 representation of a number n is 27,006,000,052, base 9. What is the remainder when n is divided by 5? Okay, so we have, this will be the 9 to the power of 10, 9 to the power of 9, 9 to the power of 6, 9 to the power of 1, and this will be 9 to the power of 0. Okay, so now how do we solve this? So we have 2 times 9 to the power of 10, plus 7 times 9 to the power of 9, plus 6 times 9 to the power of 6, plus 5 times 9, plus 2. So now we need to take this mod 5. So if we take this mod 5, we know that 5 times 9 will always be a multiple of 5, so we can just cancel this. And then when we take the powers of 9, 9 is equal to negative 1 mod 5. So this will be congruent to 2 times negative 1 to the power of 10, plus 7 times negative 1 to the power of 9, plus 6 times 9 to negative 1 to the power of 6, plus 2. So then we can just calculate this, and this will be 2 minus 7 plus 6 plus 2. If we calculate this out, we'll have this congruent to 3 mod 5. So our answer will be D, 3. Okay, problem 13. Each of 6 balls is randomly and independently painted, either black or white, with equal probability. What's the probability that every ball is different in color from more than half of the other 5 balls? So let's say we have one ball that is colored black. Then at least 3 of the other balls will have to be white. If more than 3 are black, then our condition won't be satisfied. In the same way, if one of our balls is white, there must be at least 3 black balls. That means the only case we can have is 3 whites and 3 blacks. So the number of ways to choose 3 whites and 3 blacks is the total number of ways to choose 6 balls, which is 1/2 to the power of 6, times the number of ways to arrange 3 whites and 3 blacks, which is 6 factorial over 3 factorial times 3 factorial. So this simplifies to, so this whole equation simplifies to 20. We'll have 20 over 64, which is equal to 5 over 16. So our answer is D, 5 over 16. Okay, on to question number 14. How many ordered pairs x, y of real numbers satisfy the following system of equations? X squared plus 3y is equal to 9, and absolute value of x plus absolute value of y minus 4 whole squared is equal to 1. So taking this equation over here, we get absolute value of x plus absolute value of y minus 4 is equal to plus minus 1. We can add 4 to both sides, and we get absolute value of x plus absolute value of y is equal to 3 or 5. So now we can graph this. If we draw our graph, for the value of 3, we'll get a diamond, which goes at points negative 3 comma 0, 0 comma 3, 3 comma 0, and 0 comma negative 3. In the same way, if absolute value of x plus absolute value of y is equal to 5, we'll have a bigger diamond with side lengths 0 comma negative 5, 5 comma 0, 0 comma 5, and negative 5 comma 0. Now let's take the graph for our first equation. X squared plus 3y is equal to 9. If you graph this, you'll get a parabola, which will intersect with the inner diamond at points negative 3 comma 0, 0 comma negative 3, and 3 comma 0. And it'll intersect with the outer diamond at these 2 points. So as here we get a total of 5 intersection points. So our answer is B, 5. Okay, so problem 15. Isosceles triangle ABC has AB equal AC is equal to 3 root 6, and a circle with radius 5 root 2 is tangent to the line AB at B and the line AC at C. What is the area of the circle that passes through vertices A, B, and C? Okay, so let's take the center of our circle O1. Then we know that we'll have a right angle here and a right angle here because we hit the circle. And the circle is always tangent to a line at a right angle. So then we know that ABO1C is a cyclic quadrilateral because opposite angles sum to 180. For the angle ABO1 and angle ACO1 are both 90, and therefore angle BAC and angle BO1C will also both sum to 180. So we know that the circle that goes around triangle ABC is the circle that the cyclic quadrilateral inscribes. So now, since we know that angle ABO1 is a right angle, we can figure out length AO1. So if BA is 3 root 6 and BO1 is 5 root 2, we know the total length of AO is 3 root 6 squared plus 5 root 2 squared, which is 54 plus the square root of this. So square root of 54 plus 50, which is square root of 108. So you have AO1 is equal to root 108. Also, since angle ABO1 is a right angle, we know that ABO1 is an inscribed right triangle in a circle, which means AO1 is the diameter. So that means the radius of the circle will be AO1 over 2, which is equal to root 108 over 2, which is root 27. So therefore, the area of our circle will be root 27 squared pi, which is equal to 27 pi. So our answer is D, 27 pi. Thanks for watching, and I hope to see you soon.